I'm Anil Kumar sharing with you 3 important questions from my student Anna, and I hope solution of these problems will help you to understand the concept of finding distance from a point to the plane. The questions are: number 1, the distance from a point R 3 minus 3 1 to the plane with the equation ax minus 2y plus 6z equals to 0 is 3. Determine the possible value of A for which this is true. Question number 2. Point A 1 2 3, B minus 3 minus 1 2 and C 13 4 minus 1 lie on the same plane. Determine the distance from point 1 minus 1 1 to the plane containing these points. Question number 3 is: determine distance of the plane with x, y, z intercepts at 1, 2 and 3 respectively from the origin. So this set of questions will help you understand all the concepts which you need to know to find distance from a point to a plane. In general, equation of a plane can be written as ax plus by plus cz plus d equals to 0, and in that case distance d from a point, let me write distance from a point, let's say P, which is x0 y0 z0, is given by the expression d equals to ax0 plus by0 plus c z0 plus d, the absolute value of this, since distance is always positive, divided by the magnitude of normal vector, which is a square plus b square plus c square square root. So that is one formula which you need to know to solve these questions. The second one is relating the equation of plane with intercepts, right? So you could actually write the equation with intercepts. So it says determine distance of plane with x, y, z intercepts at 1, 2, 3 respectively from the origin. So let us say the intercepts are a, b, c. In that case, we could write the equation as d over a plus b over b plus c, rather I should write x over a plus y over b, where a, b, c are x, y and z intercepts. Z over c equals to 1, right? So that is the equation of a plane with given intercepts. You can actually pause the video, answer these questions, and then look into my suggestions. So let's begin to solve them. Question number 1 is point A, B and C are given. They lie on the plane. We need to determine distance from point 1 minus 1 1 to the plane. So we'll actually develop Cartesian equation. Of plane with the help of given points. So point A and B will give us one direction vector. AB could be written as minus 3 minus 1, which is minus 4, minus 1 minus 2, which is minus 3, and 2 minus 3 as minus 1. We can also calculate AC. So AC could be given as 13 minus 1, which is 12, 4 minus 2, which is 2, and minus 1 take away 3 will be minus 4. So these are the direction vectors. We can get normal as cross product of AB and AC, right? So normal will be equal to minus 4 minus 3 minus 1 cross product with 12 2 minus 4, right? So you can apply the method known to you to find the cross products. Here is how it could be done. Write these -3, -1, -4, -3, and then we can write this starting from the center, 2, -4, 12, ending with 2. Now the I component will be this minus that, right? So that is the I component. So we get 3 times, so we can write normal as 3 times -3 minus becomes positive 12, minus 2 times 1 minus it becomes +1, so that becomes the I component. And then with J we'll do this, which is -12 minus of 16, and the K component will be -8 minus becomes positive 36, right? Now this could be also written as 12, sorry, this is 2, right? Sorry, 2. So we get 14 minus 28, and this is 36 minus 8 as plus 28. Well, when taking normal components, we can actually take 14 common. So the direction could actually be written as 1 minus 2, 2, right? So that becomes the normal vector for the given situation. Now, since that is the normal vector, the equation of plane can now be written as A x plus by plus cz plus d equals to 0, where a, b, c are 1 minus 2, 2. So I could write this as equal to x minus 2y plus 2z plus d equals to 0. To find the value of d, we can substitute any one of these points. Let me take a as 1, 2, 3 here. In that case, substituting 1 for x, 2 for y, so minus 2 times 2, plus 3 for z, we get 2 times 3, plus d equals to 0, and that gives us the value of d as equal to, we have 2 times 3 as 6, let me take it to the other side, minus 6, 2 times 2 as 4, minus 1, which is minus 7 plus 4, which is minus 3, right? So that becomes the value of d. Substituting minus 3 for d, we get the equation of the plane. Let me rewrite the equation of the plane pi as x minus 2y plus 2z minus 3 equals to 0. Now that is the equation of the plane, the Cartesian equation. We need to find the distance. So we can apply the distance formula, which is distance equals to absolute value of, we'll substitute 1 minus 1 in this equation. So we get 1, minus and minus becomes positive 2. Then for 1 it becomes positive 2 minus 3 divided by square root of a square, which is 1 square, plus 2 square, which is 4, and 2 square, which is again 4, right? So that is what we get. So that gives us 2 plus 2, 4, 4 plus 1, 5, take away 3 is 2, over 4 plus 4, 8 plus 1, 9, square root of 9, or you get 2 over 3 as the distance, right? So the answer here is that the distance from the given point is 2 over 3, right? So I hope the concept is absolutely clear. Please feel free to go through it once again. Now let's take up the next question. The next question here is, distance from the point R, which is 3 minus 3, 1, to the plane ax minus 2y plus 6c equals to 0 is 3. determine the possible value of A for which this is true. So here we are given the distance, right? That is to say that in this formula, distance equals to AX0 plus BY0 plus CZ0 plus D, absolute value, divided by square root of A square plus B square plus C square. We are given the distance as 3, so we could write this as 3 equals to, from the point is 3 minus 3, 1. A is not known to us, so this is what we need to find. So we'll substitute 3 for x0. So let me write 3a here, right? Minus 3 for b. So in this equation, minus 3 for y0, we have, let me rewrite the equation first. So what we have here is a, we'll write x0, b is minus 2y0 plus 6 z0, d is 0, right? So that is all, over square root of a square plus minus 2 square plus 6 square. That is what we have. Now we will substitute x, y, and z points right here. So 3a minus becomes positive 6. And 1 times 6 is again positive 6. So that becomes the numerator divided by square root of a square plus 4 plus 36. So this gives you the equation 3 equals to 3a plus 6 is 12 over square root of a square plus 36 plus 4 is 40. Now you could simplify this dividing by 3. So what we get here, and then you can cross multiply also. We can get 1 equals to 3 common, a plus 4 over square root of a square plus 40, right? So I divided both sides by 3. Okay, let us cross multiply and simplify. So we have a square plus 40 square root equals to a plus 4. Now if I square both sides, we can get rid of square root and solve. So I get a square plus 40 equals to, square will be a square plus 2ab, which is 8a plus 16. Now bringing all the terms together with a, we will get 40 minus 16 equals to a square cancel is equals to 8a, and that is 8a equals to, taking away we get 24 equals to 8a, or a equals to 24 over 8, which is 3. So a is 3. So we get our answer, a equals to 3. Now let's take up the last question. I hope the steps are absolutely clear. The last question here is, we need to determine distance of the plane with x, y, z intercepts at 1, 2, and 3 respectively from origin. Now generally the equation is given in Cartesian form, ax plus by plus cz plus d equals to 0. Now we can always rearrange this equation, writing this as ax plus by plus cz equals to minus t. Now if I divide by minus t, I get ax over minus t plus by over minus t plus cz over minus t equals to 1, minus t divided by minus v. And that could be written as x over minus d over a plus b over minus d over b plus c over minus d over c, right, equals to 1. Now what is this? Minus d over a. Well, these are x, y, and z intercepts, right? So you could write this as x over a plus b over b plus c over, actually I should have written capital Y and z here. Y and z here, right? Over c equals to 1. So these are x, y, z intercepts, right? So I quickly derived this equation. You should understand that to find x, y, z intercepts, we have to basically substitute y and z 0 for getting x intercept, right? So if I substitute 0, 0 here, I get ax plus d equals to 0. That simplifies to x equals to minus d over a as x intercept, right? As x intercept. So you get this, right? Minus d over a as x intercept. Similarly, you can derive the others, okay? Now, knowing the intercepts, we can actually rewrite this particular equation in Cartesian form with intercepts. See how? If I, at this stage, multiply everything by a, b, c, then what happens? Then what we get here is bc times x plus ac times y plus ab times z equals to abc. And if I rearrange, I get bc times x plus ac times y plus ab times z minus abc equals to 0. Now that is again the Cartesian form. The only difference here is that capital A has been replaced by product of y and z intercepts. Do you see that? Correct? Now this formula or this equation of the plane helps us to really calculate the distance very easily, right? Since we need to find distance from origin, which is 0, 0, 0, what we can do here is that we'll substitute 0, 0, 0. We are left with d on the top. Do you see that? So distance from origin which means 0, 0, 0. We are using this formula, right? We are using ax0 plus by0 plus cz0 plus d, absolute value, divided by square root of a square plus b square plus c square, right? So here if you substitute 0, 0, 0, you're left with d on the top, right? So the formula reduces to absolute value of d over the magnitude of normal. Do you get the idea, right? So that becomes the formula. Now in our case, we know what A, B, C are, right? So this is A for us. Let me write down. X intercept A, this is B and that is C. Substituting these values, we can actually do or find the distance. So we know that D is equal to minus of ABC, which is ABC. That means the value of D is basically equals to 1 times 2 times 3, which is 6, right? And the coefficients A, B, C will substitute here, right? So what we get here as the equation of plane pi, B times C, that means 6, 2 times 3. We get 6x plus A times C, which is 1 times 3, is 3y. AB is 1 times 2, which is plus 2z minus ABC 1, 2, 3. When you multiply, you get 6 equals to 0. That is the equation. You get an idea, right? So let's find out the distance now. Absolute value of minus 6 divided by square root of 6 square plus 3 square plus 2 square. You get it? Which is 6 over square root of 36 plus 9 plus 4, which is 49 or 6 over 7, correct? So 49, 6 over 7. So the answer here is that the distance from origin for the given plane is 6 over 7. So I hope that is absolutely clear. The concept is clear to you. So with that, we have done 3 good questions on finding distance from point to a plane, right? So from a point to plane. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks a lot for watching and all the best.